with some Python programming for writing concurrent programs. So let's just quickly revise what we had done. So I'll be using Python. The screen is visible.
Yes, ma'am.
Okay. So about the async IO module. So I mentioned about the async IO module. What does it do? Async IO. I introduced this library to you yesterday. And with a very good example which you should remember. So I'll repeat again. Async IO is basically, it's a Python library which is used to write concurrent, asynchronous and cooperative code in a sequential manner. I had made this point clear. So we are going to write concurrent, asynchronous and cooperative programs, and that is why this is the library that we are going to use, async IO, right? And I also mentioned about what is asynchronous and synchronous, giving you some examples. What is preemptive multitasking and cooperative multitasking, and how do you actually async IO is basically used as a foundation for multiple Python asynchronous frameworks. And because of that, we can write some concurrent programming. And then how to execute coroutines using the event loop. Then how do you block a coroutine, write a block of coroutines for some specific time duration. That is async io.sleep was the function that I had told you that we are going to use. And then finally how to execute coroutines concurrently. So this was what was told yesterday, right? So now let's start writing a simple program. So I'll try to import async IO. The font is fine. So I'm importing the library async IO. I'm making use of Python 3.7 if you can see the version of Python that I'm using. So for concurrent programs, I think you should use 3.7 onwards. 3.8 if 3.8 is available. Whatever version is available currently, use that. Because if you use a lower version than 3.7, maybe some of the functions which are available here for writing concurrent programs will not be, it does not work. So we are importing the library async IO, and then we'll just define a function, a main function async and def. This means that the function is a concurrent program or a concurrent function. And then we'll just simply write a print function saying, and we'll make this function wait. Print is also a function, right? So we'll make this function wait for some time. So we'll write await async IO dot sleep, and we'll make it sleep for 2 seconds. And then again we'll print learning. So this is a simple code that has been written. So now in order to make this, in order to run this, because it is async, right? Since as soon as we write the keyword async here, this makes the function concurrent, or it acts like a coroutine. So we need to use loop, get event loop in order to run this. So we'll just write this. I had shown you the syntax yesterday. Async IO dot get event and then loop dot run until complete, and you have to write run the main program. And finally, after the entire both the programs or both the coroutines are run, you have to close the loop. So it is loop dot close. So this is a simple function written. I'll just write this. So I have saved this program and I'll just run this. So there's a runtime error, but if you look at the execution part here, so we had the string printed here first. After the string gets printed, it is sleeping for 2 seconds and then it is printing learning. Now look at this particular screen where the output is displayed and try to understand how it is breaking that function. It is making it sleep for 2 seconds and then it is printing learning. I'll run the code again. You look at this particular screen. Did you see this? Happy is printing first and then after 2 seconds learning is printing. So this is because of await async io.sleep. So this is just a simple demo showing that we can pause the execution of the next function, or the user can control the execution of the modules or of the coroutines. So this is a simple function that we had written, but now we'll try to write something different. We'll write a simple Python program first, which will a simple async IO framework we can use, which will just asynchronously count down something. It is just a countdown. Countdown in the sense, if you start the countdown from 3, then it will go to 2 and then 1. If you start from 5, it will be 5, 4, 3, 2, 1. So it's just counting downwards. So we'll write a simple function for this. And we need time, so we'll use time, input time. Is this screen visible? Just tell me, otherwise I'll be...
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
So we are writing a function called as countdown, and we'll display the name of the character that is to be displayed and what is the delay amount. Like delay specifies the time that we want to make that function sleep. Have this, but you need to be familiar with Python as well, okay? Because I'm not going to teach you all the details of the Python language. So only the basic concepts will be explained here. So I'm taking some ordinal value of A. So I'll start from, I'll take some value of n as 5 and loop it. I'll make it sleep for the duration of the delay. And what is the duration? Duration is standard. I'm using the predefined functions here. Of counter Can somebody explain me what I'm writing? Maybe the syntax of Python syntax. Just let me know this. this function. Yeah, so this is the code that we have written. Import time, we are defining this function. Now this is here in this program, I am not using async IO. I have not made the function as a coroutine. It is a simple function. It is a simple function called as countdown. So what is this going to do? What is this line doing? Now basically what is this program for? I'll just tell you that before we go into the details. Now what the goal of this example is to understand the asynchronous nature of overlapping the processing and waiting times of independent tasks, which we have seen yesterday. How like the appetizer, the course, the main course and the dessert. How did we overlap the processing, waiting time and the cooking time? So that we have seen. The same thing we are doing here. We are trying to overlap the processing and waiting time of independent tasks. And we are going to analyze a countdown function. This is the countdown function that we have written, right? That will take in a string and a delay time. So we are passing a string. String could be, these are the strings. A, B, C are the strings that we have written. So it is taking a string and a delay time. It will then count down from 5, right? Since we have initialized the value of n as 5, it will start counting down from 5. From 5 to 4 to 3 to 1 in seconds. And while printing out the time that is lapsed between the beginning of the function's execution and the input string. So it will just print the countdown from 5 onwards. And what we are doing in the main program is we are calling the countdown function. So suppose this is your main program and we are calling the countdown function and on the letters ABC. So we are just using ABC as the strings here. And the delay is different. For A it is 1, for B it is 0.8 and 0.8 seconds and 0.5 seconds. And after running this entire code, the output is, you tell me what will be the output. So or shall I run and show you what is the output and then maybe you will understand what the code is all about. Some mistake in this. Print percent dot for f slash t. We missed out one argument here. See, it started printing from 5, 4, 3, 2, 1. So we finished with A and then it started with B. And for B, the time is 0.8 seconds and for C it is 0.5 seconds. So this is how it will execute. Right now what it is doing is it is executing in a sequential fashion. If you could see this output screen, we have all A values printed first. So this function is printed first. Then we have B. So this function is printing next and then this function. So this is the output that we are getting. So in this case what is happening is we are trying to run this program in a sequential manner. From the output, is it clear? We are trying to run this program in a sequential manner. So this is the time that is required. So how can we make this program's execution time lesser than that is required in the sequential manner? So so if you see the numbers at the beginning of the lines, they indicate the total number of seconds. This. It is the number of seconds that are elapsed from the beginning of the program. And you can see that the program counted down for letters A first with 1 second interval. Then it moved to letter B with 0.8 second intervals and then to letter C with 0.5 seconds interval. and this is purely sequential. Sequential synchronous program. So try to understand the difference now, because now next we'll move to asynchronous. So this is a purely sequential synchronous program, since there is no overlapping between processing and waiting time, right? So, and we don't have any delay in this. So one after the other it is executing. So there's no overlapping between the processing and waiting time. And if you look at the entire code here, how much time does it, how much time, this was the last time that it took, right? So the total time approximately, it took approximately 11.65 seconds to run this entire code. How much time did it take when we are running it in a sequential fashion? This is very crucial here. Try to understand this. So the total time taken to run this code is 11.69. That is why we had this delay and time here. Okay. Just to compute like what is the time required for the program to run. Now which can be, you know, which is the sum of the counting down time for all the three letters. This total time required for running the program 11.6596 is nothing but the sum of the counting down times of all the three letters A, B and C. So 1 second into 5 for A, 0.8 seconds into 5 for B, and 0.5 seconds into 5 for C. So this is, now if you change this, like suppose I just reduce this count. This is how it will execute. So what is the time that it is taking? 7.0040. So this is the amount of time that it takes. So now keeping this idea behind asynchronous in mind, we should see that it is actually possible to convert this program to asynchronous one. Okay, so let's suppose that during the first second of the program, while we are waiting to count down the letter A, we can switch the task. Now we are switching from A to B. Okay, we can switch the task to move to other letters. Okay, so we'll implement this setup for all the letters inside the countdown function. So we need to change it a bit. So theoretically, what is the difference is now that all the counting down tasks are coroutines. If you look at these three are coroutines, right? It's a coroutine. So, so we want to write this in an asynchronous fashion. So we should achieve better execution time and responsiveness for our program, better than 7.0040. If we are trying to overlap the tasks, right? So let's see what is the like how best the execution time or the responsiveness of the program can be improved. Now we have seen that all the three tasks here, 1, 2, 3, A, B, C, all these three tasks are processed independently. The countdown messages should be printed out of order. Like it will jump, right? It will jump from A to B or B to C. And let's write the asynchronous program in that manner. So first we'll have to make, so I'll make changes in this program itself. So just remember this time, it is 7.0040. So let us do it asynchronously and see if we can change the execution time. So first change, that is we have to make the program asynchronous. So to do this, we first need to make the countdown function into a coroutine. And we need to specify a point inside the function to be a task switching event, right? So like in other words, we will have to add the keyword async. So I'll add the keyword async here. So as soon as I add this keyword async here, countdown function now becomes a coroutine. Coroutine means in Python it is called as coroutine, but it is actually a concurrent program. And instead of time.sleep function that we had here, okay, so that we had written this function because it was sequential. So instead of time.sleep function, we'll be using async io.sleep function here, because it is a coroutine. Now we are making the coroutine function sleep. So, and we have to use this function along with the keyword called as await, right? And the rest of the function will remain the same. So let's try and implement this. So where this will be, I'll just change this to await async io dot sleep, right? So rest everything is going to be same. Duration, print. Yeah, and now for the main program, so this was what we had written for the main program, right? So we'll have to make some changes here. So till here this is fine. Now for the main program we will need to initialize and manage an event loop. So as soon as you are making this function as a coroutine, you need to make use initialize and manage an event loop. So specifically we will have to create an empty event loop with async io.get event loop. This method we need to use, and add all the three counting down tasks into the task queue. So let's do that. So we will write this as loop is equal to async io dot get event loop, and we'll write all the tasks. Task is equal to, we need to put it in square bracket, and we will write loop dot create task. We'll just write this. Okay, comma, the same thing needs to be copied again. Now this is b with 0.8. So I'll just push it down. So we have added all the tasks. So loop dot create underscore task countdown A, B and C here, right? And then the loop is closed, so I'll just put this down so that it's easy to understand. And now this start is equal to time dot perf counter. And now loop dot until complete. So this is what you write, and yes, then we are done. So async IO, just go through what are the changes that we made. Yeah, we don't have this library, so we need to import async IO. Okay, so that error also goes away. Just see what changes we had made. Import time, import async IO, async def countdown, indents n equal to 3, while n, then you're making the process sleep, the duration, some printf statement, loop task is equal to this 3 tasks. Yeah, so shall I take another kernel so that you get the okay, so I'll run this. You saw this, it executed C first, so we don't know which it will execute first. So it executed C because it was only 0.5 duration. So it started with the task which had a least delay. So 0.5 and then B and then A. Again it switched to 2 C. So C it executed continuously, then B, A, B, A again. So this is the sequence it executed. And look at the time that we get. 3.0 something something. Which is much better than this particular time that we got here. So it is 7, almost half the time. So when you are just running these in an overlapped fashion, you get, there is an improvement in the execution time. Could you notice this difference? So you can see that asynchronous program can improve the execution time and responsiveness of any program that you write. So you just need to figure out which tasks can be overlapped. So instead of executing individual tasks sequentially, our program is now switching between different countdowns and their overlaps, and it is overlapping their processing or waiting times. So that is why we see that different letters are being printed. And this is how we are achieving concurrent programming. So at the beginning of the program, instead of waiting for the whole first second to print out the first message A is equal to C, it starts with C is equal to 3. Right? So this task switching property of the asynchronous program makes it more responsive because we are allowing it to switch. Right? So instead of hanging for 1 second, because first if it prints A for 1 second, instead of waiting for that 1 second, meanwhile it can print C and B, right? So it does not wait for A, it goes on printing C, then B and so on. So depending on the time, it is, since C is the shortest waiting time, it will print that. So this corresponds to that, like we can also say that the execution time would be right around the time it takes to execute the longest or the largest task. Right? Is this clear? Any doubts? Any queries? Or is it understood? You have to practice all these programs, okay? Okay. So now let's write another program. Now this is going to talk about how to block functions. Right now, like in our original, like in this program, we had, okay, I had erased this. We had used, instead of this, we had used time.sleep function, which is equivalent from the async IO module. So in async IO module, it is await async IO.sleep. Now, time.sleep is by nature a blocking function, which means that it cannot be used to implement a task switching event. You cannot, if you just write time.sleep, then that function does not allow you to switch the task. And for that reason, we had to make use of, so we replace that line with await async IO.sleep. Right? So after running this, using this, the switching was happening. We could see the switching. So now let us write a program, like to find prime, like to just find out whether a given number is a prime number or no. Okay. So this example, this code, first we'll write it in a synchronous manner, and then we'll see how we can change the asynchronous prime checking code to asynchronous one. So for this function, so it is a very simple function just to test whether a number is prime. So we need to import from math library. So I will import the square root function. I will define the function as is prime x, and print so now if x is less than 2, then what will be the print message? If x is less than 2, if x is less than 2, what is the message that we need to print? That number is not a prime number. Basic concepts of maths. Okay, so we printed this. Now we'll have a elif statement here. Now we check that it is equal to 2. So if it is equal to 2, we print is a prime number. If x is equal to 2, it is a prime number. And now if it is not equal to 2, if it is some other number, then what do we do? Now, some other number means now we have to divide the number x mod 2 is equal to 0. Then what do we do? Then we print.
Ma'am, can you increase the font?
Okay. So we print just check the three condition. If x is less than 2, print I is not a prime number. If x is equal to 2, I is a prime number. If x mod 2 is equal to 0, then I is not a prime number. Right? Yes. Else we'll limit equal to what is this condition? Check for the indentations also, otherwise we'll get some errors. Okay, so this is what we are doing for checking the code, and then finally our main program. We'll call it for some huge number. Now we'll check for some huge number, because if it is a very large number that we have to check, it will take more time. So different combinations we'll try. 4 to 7. Okay, so this is what we had written now. So just check if there are any errors. See, it started processing the first prime number because it is very large, it is taking time. Okay, now this is sequential. I have not introduced any coroutines here. I have not made the program asynchronous. So what it did, it started processing this. It took time for finding out whether this number is a prime number, but it gave that answer first. Then it started processing the next number. Okay, then it gave this as a prime number and so on. So could you see this difference? Now this was a simple sequential program that we had written. Is this understood? Give me some response.
Yes, ma'am.
So now we want to convert this program into a asynchronous program. So what should we do? Can you convert this program to asynchronous now? What we need to do? What changes we need to this to do in the same program? So I'll just copy this code into a new file and let's see what changes we can make. We'll call this as, I'll save this program as so we'll have this, like this is the sequential one and this is the concurrent one. So I have already explained like how this was changed to concurrent program. We changed this now. So this is sequential and now we want to change this to concurrent. Tell me the changes. I'll do the first thing. Import async.io. So that is the first library that gets included. Next.
Then convert the function asynchronous.
Yeah. So this will be, this is the next. Now any changes in this part? Tell me the third change. We need to add async.sleep na, because we are going to make the functions alternatively sleep. Now if this particular task is going to require more time, I will make it sleep. So where do you make it sleep?
In for loop.
Yeah, in for loop. So maybe after this return statement, I can include one else if I'll check the condition. I mod suppose some 1000 value is equal to, and I will call await async.io dot only for 0 seconds because we want the next number. Just for 0 seconds we'll make the process sleep and then it will start the next one. So or we'll increase the time later on. That's it. And next, So we have this main program here. Now after this, so this was one change. How about the main program now? We need to define the main program, right? Okay, I'll write the main program for you.
Then add a loop.
Async, def and main. So this is what you need to change this function to. And you have to add the tasks now. So let us see what tasks we can add. So task 1 is loop dot create task, and we are going to call this function. So we are just creating tasks. This will be task 2 equal to loop dot task, and finally we have task 3 loop dot create task, right? Right? So this, and then finally you have to actually make use of the try exception block. If you have learned Java, you'll understand what is this. You have to make use of the, and after this, like after this you have to write await dot async io dot wait. Task 1 comma task 2 comma task 3, and after this you have to write the try catch block. So in this block you have to write get event loop and loop dot run until complete. Error. Yes, so this is, we are just putting this in a try catch block and raising an exception. Just go through the code. Just see what are the changes that we have made. And you can also, if you want to add the time factor, you can also compute the time that is required for the entire execution of this code. Shall I run this? See, there is an error here because loop.close sometimes does not work properly. It says that cannot close a running event loop, And the reason for this is because this particular function which is running, it does not give the output immediately, and for the then it starts. Look at this first. I can't increase the font size here, but I'll show it. See this. So what it does is it is processing this number first, and it does not give us the output as against the output. Yeah, so it processed this number first for the sequential, and it immediately gave the solution for this. But for this P4 program, what it does is it is processing this. It does not give the output. Then it started processing the second one, overlapped, and it gave that this is a prime number. It processed this, and after some time it gave that the first number is a prime number. Did you understand this? So please notice the changes. Converting a sequential program to concurrent program. So we just imported this. We had this. We changed this and this part, the main part. So this is how we need to do it. So, and these functions, please keep in mind that these create task functions, or maybe depending on what version of Python you're using, you will have to use some different functions. So you can just Google it and see what are the functions instead of create task, or instead of run until complete. If it works, it's fine. But if it is not working, then you just check. You need to practice this and see whether these functions are working for you. Okay. So there are different functions also available. Understood all these concepts? What I meant by concurrent? How can we include the time component? Like suppose in the sequential program I want to compute the time that is required for this execution of the program. How will we do this? Can you just tell me how this function can be written here? How many of you actually have worked on Python?
Some basic, ma'am.
Only basic, but now we are going very deep into Python. Maybe not Python, this is just we are going to learn Erlang actually. Python is just to make the things clear, what is sequential and what is concurrent, and how can you achieve, or how can you write concurrent programs. So I just want to compute the execution time, total execution time required for this code. So we can find out whether we are really improving on the execution time if we are writing concurrent program for this particular program. Or in this program, anywhere, like we just want to find the time.
Can we have to add a duration equal to time dot ref this function or line in it?
Where do we add that?
After the sleep, wait asynchronous sleep.
After this?
No, no, no. Before the
This one,
yeah,
line number 19.
yes.
What do I write?
Duration equal to time.
We had written somewhere here. This one.
Yeah. Yes, ma'am. Yeah, I
Shall I
think so.
copy this?
Yeah.
Indentation is right.
Yes, ma'am. And we have to write a print function also.
Done. It is we tell me what or is this enough? I've added
Okay.
this. It's giving me
No,
some error here. Undefined name start local variable duration. बोलो. Okay, we can do this that as an homework. Try this. I don't know. I'll execute this and see whether it is working. It's giving me errors. See, for that statement itself, 21. Here only it is showing me that error. Start is not defined. Okay. So as for P3 and P4, this is a sequential, this is concurrent. I want you to introduce a time factor here which will compute the total execution time required for this process and for this entire process. And the reason for doing is we will understand whether overlapping the tasks gives us a better execution time. Okay, so can you do this as homework?
we can try, ma'am.
Try नहीं करना ही है.